Hi, my name is Paul Herickx. I am the Environment Agency Project Manager for the fish passage works that we were doing on the River Teme as part of the Unlocking the Severn project. This is the presentation over how we develop those designs. So first of all, who am I? This is me. I am a civil environmental engineer with about 20 years construction experience. This started in 2001 as a site labourer. I then joined a contractor called Weir-Rock in 2002. This then led to me going to university and then becoming a sponsored student in 2008, graduated in 2010 and joined them permanently from then. I worked on the Midlands Fish Pass programme for a year as an engineer and then moved up to Scotland and spent 2 years working up there as a site supervisor on the Elgin Flood Alleviation Scheme. I then eventually joined the EA in 2015 as project manager, promoted to project executive in 2019. I've worked across all of the Midlands, prominently delivering fish and eel passage. This includes the works on the Severn, but we were currently under construction for a 200 metre long, 8 metre wide, deep vertical slot fish pass on the River Teme near Nottingham. So obviously the Shad's Podium is in Worcester, so very close to where the work's been taking place, and just highlighted there where the two barriers are that we've been working on for the team. So the actual team itself is SSSI. This means that we've got a number of things we need to adhere to with our design. We were doing a partial removal of Powick weir, and with Knightsford Bridge gauging weir, we were able to adapt the gauging station to become a bespoke rock ramp. This has led to over 60 kilometres of environmental enhancement to the SSSI. It's cost us about £2.5 million to do the works. And this has been delivered through the Environment Agency's WEM framework by a joint venture called Team Reynolds, that consisting of the designer of Haskell and DHV and the contractor Kia. There was a lot of design constraints which we'll go into shortly. So with Powick itself, obviously the most important thing that we need to ensure is that we've got the correct conditions for shad passage. This includes laminar flow. They swim in shoals, so therefore there's a sort of space consideration. The migratory period is from April to June. It's largely dictated by the temperature of the water. This obviously influences the design with the flows that is expected around that sort of time of year. And minimum depth of water of about 450 millimetres. Just downstream of Powick Bridge, we've got just downstream of Powick Weir, we've got Old Powick Bridge, which is a Grade 1 listed structure. We had to ensure that there was summer flows in the mill itself, and there's a number of ancient milling rights we need to adhere to. The lead leads on to the hydroelectric power station, which is a Grade 2 listed structure, one of the first in the world. Therefore, there's a lot of archaeology in the location. It's a very important location historically. It was the site of the first English Civil War, and therefore there's a lot of very interesting land there. This is the sign sort of highlighting that. There's a lot of local angling clubs that we're working alongside, and there's a lot of considerations for public safety in the location as well. We've got common land, which is the hatched area on the map here. Again, there's a number of considerations for working in and around common lands, which we had to get a permit for. Livestock movement between the north and south banks. Clearly, if you're lowering the water level from the removal of the structure there, there's the potential for livestock movement between them at low flows. Therefore, again, we had to make sure that all of these were considered in the licenses and the permits and the concepts for the works. And very importantly, we are unable to increase any flood risk to the area. And this is a very important part of the design development. So just a little bit of information about what it looked like before we started any works. This is Powick Weir. We've got two road sheet piles, upstream and downstream, and there's a concrete slab on the right hand side you're looking at it. This was built in the 1990s. It also contained a Alaskan A fish pass, which was sort of suitable for certain species, salmonids in particular, but not suitable for shad, which is obviously the most important part of our design development. That particular structure replaced a sluice that was built in the 1950s, but there's been lots of different types of structures there over the years. Like I said, it's the first barrier on the team above the confluence with the River Teme, which is about 1 kilometre just downstream. So these are the design drawings for the sections there. So on this drawing here, you can see the upstream sheet pile rows. They're the vertical sort of rectangles you're looking at them. We did a number of runs of hydraulic model to ascertain what the water levels would be under a number of different scenarios, and these were cut down to facilitate the passage there accordingly. To ensure we had a stable structure afterwards, we then placed rock on top of the cut down piles. And you can sort of see there, the rock is about 3/4 of a metre thick on average. Really importantly, under low flow, so I had to make sure that we had the right conditions there. The river is quite wide, so we created a low flow channel, and you can sort of see that's that sort of slightly concave shape we have just there. On the downstream, we also had to do similar sort of works, and we removed the piles down to a certain level. Again, then had to sort of place rock to stabilise the bed that was there. We were able to leave some of the sheet piles in place to give ourselves even more confidence over the stability of the structure that was there. And really importantly, again, we had to sort of infill part of the scour hole downstream to prevent the rock from migrating into that over. So looking at the design from above, again, you can sort of see the sheet piles that are there. They are, you know, obviously important for stability, but we had to remove those accordingly to facilitate the correct design. Placing the rock in there to construct the low flow channel enabled us to play around with the design a little bit and make sure that it was going to be optimal for shad passage. And really importantly, making sure that there was no increase in public safety risk, actually trying to mitigate against that as far as possible. So placing rock into the river about 1 in 3 slope to prevent any sort of falls from height. So this is the works post construction. You can sort of see that we've got flows down into the mill leat. You can also sort of see there that we've got the low flow channel, and the white band you can see is a short sort of section that we painted to be able to monitor sort of shad passage at the right times of year. You can sort of see here where we've got some very shallow water over where we place rock to stabilise the bed across the main river itself. And then you can sort of see here the rock placed into the river for public safety considerations. Finally, the scour hole itself it's also been infilled to ensure that the rock doesn't migrate further. So just a quick look at the works for Knightsford Bridge as well. You can sort of see here on the left hand side we have the works pre-construction. So that's where the gauge and weir is in place. You can sort of see the white water where the water is cascading down the face of the weir. And then on the right hand side you can see that we've got no white water there. And you can see that the water is a much more laminar flow. So just a little bit more about the design for Knightsford Bridge. Similarly to Powick, obviously we've got very similar conditions that we need to adhere to. We had to slightly adjust the wind and water depth, bearing in mind the site constraints that we had. So 400mm is what we're working to for Knightsford Bridge. We also had to retain the gauging station function. We've replaced it with what's called a Doppler, which is fitted to the abutment upstream, just upstream for the bridge. Again, working with the local angling clubs, it's a very popular fishing location. So, you know, again, sort of lots of dialogue with those. Public safety considerations similarly. And as well as the necessary licenses and permits and consents, and no increase to flood risk. So very similar constraints to Powick, and really important to make sure that we get the balance right. So this is the as-built drawing when the gauging station was built back in the 90s. So upstream, we had to retain a minimum water depth for gauging purposes. This is about 1 metre minimum. We also had to reduce the water velocity over the crest As it goes over the crest, the water increases in velocity due to the hydraulic conditions, and therefore that was actually what the biggest barrier was. In addition to that, we had to increase water depth over the centre of the structure in particular. The flat V nature of the gauge in Weir meant that this was one of the most important considerations to work to. So just going into the design itself then, we have created a bespoke rock ramp there. It's got a shallow V profile, and that has enabled the centre of the structure to be slightly deeper than the edges. So under low flows, we've got the right conditions there. Similarly, in sort of concept to the low flow channel that we created at Powick. We managed to achieve this by significantly lengthening and flattening the crest of the existing weir. And on the downstream side, we filled the scour hole there to ensure, again, we've got the right sort of laminar flows and to make everything sort of stable with the structure. There's quite a bespoke sort of toe to the structure there, using sort of soliform bags to make sure that, again, we don't have any risks of the structure migrating over time. So just a quick sort of video just to sort of show the flows themselves. So you see there, that flow down the centre of the river. And finally, we have a quick sort of time-lapse video of the construction work at Powick itself. This was just to ensure that we can record for future and use the information to help us with our development of designs in other similar works. Okay, so that's the presentation. I look forward to meeting some of you at the symposium itself, and hope you have enjoyed this. And yeah, thanks so much.